So in this video, I'm going to show you a step-by-step tutorial how to create a perfect fitting foam that's going to protect your electric devices inside your transport cases. And this is not just a step-by-step tutorial, this is as well an offer to get to know better our customers in the packaging industries. So just for the customers from the packaging industries, that will present me some cases how to use 3D scanning in the packaging industries or in industries that have a really need for special packaging. They can send me under my email contact@3dscanacademy.de some case and some examples. And for these customers, this is just a one-time offer. There will be the 10 first who write me will receive an offer from me with 10% discount on the already really good priced HX Red Bundle. That means including Geomagic Essentials and Solid Edge. So for all of you, just enjoy, take a look, and if you have comments on the topic, feel free and write them below. So this is the kind of foam that I'm talking about. This is foam for protection of electric devices. And in this case, it's keeping my scanner. So you know them from different kind of applications. They are used for dumping subjects inside some boxes and avoid that they get damaged. Many times they are made of many layers. You can see it here. So this is maybe one centimeter of thickness, but applied some 10 to 20 times or 40 times. It can be depending the height that you want to cover, and they are glued together in between each other. I'm not going to destroy it, but I think you can see it like this. And we are going to build one of these. So we are right now in the laser scanning menu of the Scan IHX. We are right now ready to scan the box, and we'll select the detail that we are going to scan. I think medium detail is more than enough. So let's start to apply it. In this case, the box is inside black, so we are going to switch to the pre-selection black, what normally is really good for scanning black plastic. So instead of tuning the scanner very much, it is most of the time sufficient to start like this. I can see, okay, there are my targets, just expecting anyway, even in the black mode, that the higher brightness will help. I start to see red areas in the laser crosses here. That tells me that brightening is in the upper border. That for me is always better than the lower border, I guess. So let's start to scan and see what will happen. And this looks quite promising, so I think that should work. Let's capture as well the edges, because they are a bit more tricky, of course. They need to be seen at least by the cameras and the lasers same times. I'm not sure what you're thinking, but we are done, and this is, I think, really fast. Calculating the mesh is next. And here we are with some pretty decent result, I guess, for a few seconds of scanning, I guess. As I want to create some additional polylines and surfaces in this model, I'm not going to post-process the model in the Scan software so much, because I will export it to do this to Geomagic anyway. So I just do, let's say, some simplification, because the model still have a lot of details. Optimization is as well not wrong. That means mesh grids will homogenized and spikes will be taken out. I will choose unwatertight because in this case watertight makes no sense. It's not a closed volume, and if it tries to close it, it will end up in being something that have nothing to do with I want to or I will use. So let's apply. And here we are with the pre-result. Let's confirm. Apply means that all the functions that you have configured will be applied to the model, but they are not saved finally. So we have to confirm that to create the model like it is in the preview. Okay, so in this case I'm going to clean up that model as well, because yes, I don't want that outside layers to be captured as well. Maybe it's not necessary that I will as well use the upper part of the cover, so I'm going to use my polyline tool, what I really like. It's going to, in this case, not try to delete what is actually too much. I think it's more time that I will spend in selecting the outer areas instead of selecting what I want and go to revert. So I'm going to delete what I don't want here. Okay, so we are, let's say, quite ready. So next topic is the rest of the cover that I don't want to, and delete it. By the way, with, let's say, reverting the area that I want to stay with as well, I am deleting all the, let's say, diffuse points that you might not see in this case, because I'm, let's say, selecting everything else but what I pre-selected in the reverting. So everything like noise and so on is done and we are ready to go. So okay, right now I just have the shell that I want to use for processing and creating the shapes for the final, let's say, shape of the form. So this case, like I was explaining before, I'm going to post-process most of the scan in another software, and as fortunately until now, I hope that stays for a long time, but I'm not sure, it's included Geomagic Essentials. I'm going to directly export the result to Geomagic. So that's pretty easy, like you see, it's just a click, and we are going to switch to millimeters. That's what I want to use. You are normally asked for the mesh doctor. What we are going to apply, why not? This is always some good tool. There you see in laser line scans you always have some really small details. I didn't close them in the Einscan software. That's why I'm going to do this right now in the Geomagic software over the Doctor Mesh Doctor you can find here as well. It's a standard tool for scan repairs, and there is a really good working auto mode. You see here the arrows that you have, spikes or open areas, small holes, and we are going to apply them, and you're going to apply it until here is 0. So we are back right now. You can see that optimization is done. We have, let's say, the standard problems resolved by the auto tool. That is really cool. You have not really to think too much about, let's say, standard corrections. Just click on apply, and sometimes you have to do it more than one time to correct everything, but this time it was enough. So we say okay, we are going to leave the mesh doctor that you will find here in the scan mode mesh doctor. Right now, as we exported the model without, let's say, doing the basic work in the Einscan software, we will need to align the model to the world coordinate system to be able to work with it in the cut. So you see here there's the XYZ axis, and you see that the part is orientated somehow in the space, so we need to align that in some reasonable way that we can design surfaces for the foam. So we have to do something here. So for the base plane, it makes totally sense to use the plane where the part later on is put on the table. So I would use here that flat area. So I'm going to put up some selection tool. We can go back to the lasso. Just marking some area with left mouse button pushed, and it's, let's say, creating some flexible outside contour connected with some straight area. You can use a lot of tools actually. Here it's not so important that the marking is totally perfect, because we have a plastic part with some uncertainties. We are going to mark some area that will be fine in this case, and we are going to create some surface that will be the base plane. So we are going to say, okay, modeling surfaces, and in this case we are using best fit, because as I told you, plastic parts are not the most precise parts, so it will be totally useless to do something very, let's say, crazy and not bringing some effect or really better result for us later on. So we can give it some name. I will name it base plane, and yes, I like the old references from drawings. I say it's A because it's the first reference how the part will be positioned. So okay, I'm going to create it, and here we are, we have a base plane. Confirming it with OK. So right now, if we are going to see in your model tree that there will be, beside the scan, there will be features. So it's easy, you can show and unshow them and reuse them for other kind of the operations. So I think so far it's fine. We are going to show it because we are going to use it for other operations. Continuing. So for me, next topic is right now thinking about orientation in the space. We have the part put on the table in some way, so it's still for having a precise definition of the position in space. We have still the degree of being able to turn it on the table, so we have some rotary degree of freedom, and we can dislocate it into different directions. So to be fully defined in space and be able to align it to the coordinate system later on, we need more references. So one that I will start right now is avoid being able to turn the part, that there will just stay the dislocation. In this case, I'm preferring some planar or straight next reference, and if I'm looking at the walls, I guess they have all some kind of drafts, because this plastic part is being taken out of mold. So don't expect these walls here on the sides to be right angular to the base plane in this case. So you will have to think a little bit how to create some, let's say, straight and not moving, let's say, reference that is not inclinated for the coordinate system. So in this case, I'm going to use the back wall, I guess. Let's see. Yes, I think the front wall, this is the area where the box is opened. You can see it here, that's why I didn't delete that rest of the cover that is able to close with this articulation here. So this is front, So in the front I see that this is bended, that this is not just a draft on it, it seems to be bended as well. So I'm not going to use the front surface for the next orientation. I want something that at least is perpendicular to something else later on, and I think this wall or the back side of the wall, they are fine. So in this case I'm going to opt for the back wall here in the shell because it's longer, it gives me a better orientation, and I do something similar like I did before. So yes, let's use the lasso again, why not, it doesn't matter. We are going to pick up some area that's big enough to give it into some medium position, a good representation of the wall. So just opening up some big enough area that will represent that cover. Yes, if you are, let's say, not happy or want more, you can just use another tool and continue to mark additional areas. If you want to unmark something, I think it's Control. Let's see. Yes, it's Control in this case, and you have really a lot of tools that you can use to create a nice selection. So I can use here Align, for example, I guess. This is a line tool that it's not perpendicular aligns, that I really like. In this case it's actually maybe the best one. You are having possibility to create easily some selection that is really nice, representing that wall, finishing it with the right mouse button. And here we're doing the same. We are going to do a best fit. In this case, this surface I'm going to create is not for me a base plane or something that I will directly use for the alignment, because it is inclinated because of the draft compared to the base plane. It's not 90 degrees, so it is for me a help plane. I will name it like this, help. Plane 1. I will just use it as some additional possibility to create what I want. Come on, create. And we have that plane. It's fine. If you have, let's say, the wish to change the planes regarding the inclination, this plane is a bit, let's say, torn down, you can change that. You can create bigger size. There is some properties here where you can change it if you want to. So yes, whatever you want here. It's not needed for me. I'm just keep it simple. So right now I'm, let's say, here in thinking where I will have my CS0, that's the 0 point for the XYZ axis. I think that border here can be a good way to do it. I think here that edge or something. As I'm having as well the problem of the draft, if you will create cutting lines of that contour, you will always have some deviation because of getting bigger to the upper area. So how I will do it? Yes, I will use that corner. I'm going to use that here in more or less in the middle. Let's see, a 0. So I can do a cutting plane and create them out of them. I think this will be best. For the cutting plane, I need some plane that is cutting that contour that I created by scanning, and this is not possible with the existing plane, so I'm going to create a new plane. There should be some offset function, I guess. Let's see. There, the systems have it. Should be this one. I'm going to select one of them So it's selected the first one, the base plane, and I think something about 40 I was measuring is something in the 35, I guess. I was measuring that, but doesn't seem like quite where I wanted, so it was maybe a little bit lower. Yeah, 30, I think something about 60 was the depth. Okay, so help plane, let's keep the naming and writing the same. Let's keep it beautiful and understandable later on. So okay, we create that plane and finish. So it's help plane 2, and to create what I want, I will need right now some line that's going around the contour. So doing this is easy. It's just a tool that is named just a moment, creating a cut through, and there is different options. So first you have to select the plane that you want to use for the cut. So it's already quite fine. This is the plane I want to use for. That's fine. You have here other parameters that in this case is not so important. You can create, I think, even some offset or so. You have here some essential things to me that you are able to select how these lines will create it. They can be splines that have a really big influence on how you will be able to use that, or you can make it like just simple elements that will try to rebuild that cutting line. That's lines and bows actually, or just lines. So in the case that I'm doing an orientation, I guess I'm better off using lines actually, and bows, maybe just lines even would be fine, but I'm just going to select lines and bows. I can delete what I don't need. So let's see what's happening, and you see here already in the preview window that there is appearing some blue line that is actually created of straight lines, and bows, that means radiuses that are defined by standard mathematical definitions, so they are really straight and they have really just one radius, so it makes some things quite easier to use them. So for this I'm going to accept it, and I'll just be fine. So in this case I'm just going to use right now the next reference, that will be B in this case. Right now I can create a line for the next definition of the coordinate system later on, and this line will be created by two faces, and this will be this one, and the cutting one will be this one. So this is my reference B that I'm creating, and right now that should create a line. That's fine actually. This line represents the alignment for not being able to turn anymore that scan inside the space actually. So this is reference B. Okay. What we just need right now as last point or last topic for definition of a coordinate system in space is a point actually. We have right now that shell on the table, so this is the base plane. We cannot turn it anymore because it's aligned to that area, so we just need a point to fix it, that it's not able to be driven around in let's say following that last axis that I created, because this is not defined right now for the coordinate system. So we have to create a point where this CS0 will be. I'm just opting for the corner point here, so what I'm going to do right now is create another plane to do it, so it's like last time, not so different. Plane, best fit, it's a help plane 3, Okay, so here we are, and right now we can create this point by the reference and the help planes that I already have. So I'm going to use point, and I'm just going to use the point where that last created help plane is going to cross this axis. So this should be here in the corner, and this is point 1, and here we are. So right now we have everything that we need to define our CS0. To do this, we are going to switch to tools, and there is some button that is representing align it to the world, actually, in that world coordinate system. So we are going to switch to this mode, and here we can see what we have that we can use. So actually I want to have the Z coordinate system. Here you can see Z and XY. I want to have it upwards. So for me is XY is for me base plane 1, and you can create a pair. So this is first definition and you're fine. So next possibility is to be able to align the turning of the mesh on the part. You can see here the preview what is already defined. I'm just going to say okay, for me, let's suppose that the x-axis is let's say the long axis that we have here, and we are going to use our line 1, that's reference B. I can create a pair, and I just need right now the final definition to fix it in Y, and this is going to use the Ursprung in Germany means like the base point, it's the point 0. So we are going to use this point 1, create a pair, and you see right already here that everything is defined. So we have looking at this, would be fine if I can see more part and less from it. Regarding the definitions, you can see that Z is upside and XY is positioned, so you can do it different if you like, but for me it's absolutely fine for working in CAD later on. And here we are going to start with a new world coordinate system. So you see that everything is aligned. So for me, actually, help plane, I will save it meanwhile. Yes, it's fine. I will save it meanwhile, so I'm just be able to delete at least the help plane in this case, because I will not need it anymore. This is just for creating the line. I can create as well help plane number 2. It was as well creating line and point. I will keep point, line and base plane because I might need them. So what I'm just going to do right now is to create sketches of the cross sections that I will need for designing the foam. Okay, so being able to do the sketches, I will need planes for, let's say, creating cutting lines actually that will represent the contour of the shell inside of the box. So what I'm going to do is to switch to create new offset surface, or actually this is here like this, and I'm going to select the base plane because this is for me the orientation I want for the cutting line. To be able to cut it in the right area, I will have to create an offset. I will select something about the middle to represent the draft situation as well. Okay, I'm saying yes. And there is a cool feature in Geomagic is, let's say, creating cutting edges between planes, and let's say mesh model. I will have to select the right plane because seems to be some pre-selection that I want to. There is a lot of things you can let's say adjust, but one of the most important adjustments that you have to do is the decision. You want to have a spline that's, let's say, a complex mathematical line that's going really around your cutting area, with the advantage that it's quite complete because it can follow all the areas. It's more flexible. Or you want to use it simple mathematical, let's say, representations of the mesh that can be just lines or lines and bows. In this case, as I'm working with a conventional cut system later on, I just prefer simple representations of shapes, so I'm going to use lines and bows. And let's go to apply, and in the preview you already see that you have here some cutting line for the contours. There is, let's say, lines and bows that is representing them in the best fit interpolation, so I can directly use them later on in the cut system. So yes, I'm going to accept. I'm really happy with this one. And as there is a draft on it, I'm going to create additional ones that are a little bit above and a little bit below. As the foam is really flexible, I don't have to fear so much uncertainties, because the foam will be able to compensate that. So I'm just having some orientation. I'm just going to create it, I think I was wrong, offset based on this one. Maybe some 10 millimeters, let's see, or 20, so I get some imagination about, oops, not 200, about what the outside contour will change. That should be fine. Let's use it. We can create as well offset down, because there will be some effect as well through the draft. So I think I could have made it like this as well. There is another function, but not sure if it will be fine doing it symmetric. That's why I'm doing this manually. So in this case, I'm going to say -20 maybe. It's a bit radical. Right now you see what I mean by maybe not doing this symmetrically, because here we have the situation that in the height change here to low, the draft is having a bigger effect. So okay, I'm just going to grade it. Fine. And this is more cutting lines. So I'm going to I'm going to create the same stuff again. Let's say first on the upper area there should be the same done as well, lines and bows. That's absolutely fine. Let's create the cutting line. No, that's wrong surface. So this should be better off. This is the upper area, and here right now you can see that this is already on the border, so maybe could have been 15 as well. Anyway, so I created this line, so let's do it again. For the lower plane here is already there, so let's start. And you see that this is already done right now. I have lines and bow pieces, let's say radiuses, that I can directly start to work on the cut system. You can see them that they of course are as well not necessarily complete, because mesh wasn't complete in all the areas, but here it looks quite fine. If there is a gap in the mesh that wasn't able to be followed up by simple lines and bows, can happen that there is some breaks, but here it looks quite fine. You can see that here in the points there is the ends of the simple geometries like the bow or the line, and here there was even created two lines for creating this deformation. You can see here that in the plastic, therefore quite for sure there was a deformation. Sometimes it doesn't make sense to really copy that because it can be different in the next copy of the same item. So I'm in this case going to use that middle contour and sketch, and on this one I'm going to sketch my model. I will represent the outer contour of the form on this one. So in this case I'm switching to Pro Engineer. The workflow is pretty much the same in Solid Edge, for example, and I'm creating a new part that will represent the foam after it's cut. So giving it a proper name, start the part. So this is the basic, let's say, components like base planes, and I'm going to import the data set that I created with Geomagic that you've seen before. So not creating new, I'm just going to put it inside a part, merge it together. So here we are. You can see there is the created planes and the sketches that I made for creating the form. So right now I'm going to do an extrusion, and I'm going to use that lines and radiuses. Here you see that this is a some kind of the benefit using simple line elements, because every kind of let's say cut and similar software will be able to use them for making extrusions, what is extremely simple to do. So I'm going to mark the lines, create a sketch, and copy them. And right now I'm going to do the extrusion. So you can see that I think it will be something about 40 when I measured it right, and that's it. So right now you can see the foam, how it will look like after cutting in its original thickness, but as it's a 2D part, I don't necessarily need a 3D part. In this case, I'm just doing it because the workflow for me is really much easier. Of course, I could have sketched it directly into some software that's like AutoCAD, just 2D. I'm going to rename right now the cutting outs of the spaces for the laptop and the cables as well, like the transformator. That will be later on, if I will change it, easy for me to identify and maybe change it. And that's it. So opening right now some kind of the drawing. I just created the 2D drawing and it's here. and here I can create easy PDF export, and here we are. Right now I can create from this data some DXF 2D cutting file for any kind of the cutting systems that are, let's say, common for this kind of the form, and that's it. It was pretty easy. You will save a lot of money like this, and you, if not having such a machine at home for water jet cutting, I think it's heat wire cutting, it should be like this, and you can just use the data. You can read in each kind of the software that is for, let's say, in the G-code generation, and that's it. You can give it to some company to do it, and they will cut you that for a few bucks, and you will be able to do your own personalized, or let's say adopted packaging for your needs, and not pay a lot of money for that. So that's it. You're ready. So for all the guys who are up to purchase a scanner with me, I'm going to send that last cut example, how to create the form and the drawing and so on. I'm going to send them the video for Solid Edge as well, so they have a really ready to use one-to-one, step-by-step tutorial for their new scanner. Hope you enjoyed it. See you next time. Bye.